All right. Hello, everyone. Hope you're having a good Monday so far. Enjoying the nice weather out there today. Before we hop into today's topic, just kind of a little update on where we're at in the class. Just want to especially make sure you're aware that we're almost to spring break. We have this week and then next week of classes, and then coming up in March, the week of March 10th, is spring break. So only 2 more weeks of class until we hit spring break. The reason why that's particularly important for us is because when we get back from spring break, it'll actually already be time for our second exam. So we've got new material today that I'm going to talk to you about. We've got one more section of new material next week that I'm going to talk to you about next week, and then that's three modules, so we're going to do another exam after that. So it is coming up after spring break. Want to make sure everybody's aware of it. It's on the Thursday after you get back, so hopefully shouldn't conflict with travel plans or anything like that. But while we're on the topic of exams, just also kind of wanted to make sure that you're aware that exam regrades for exam 1 are due to me by tomorrow. So if you think one of your exam problems was graded incorrectly, which definitely happens, please make sure to get those regrade requests into me by tomorrow. I take a look at all of those myself, and you'll get those back sometime this week, hopefully. Otherwise, we're just kind of cruising along. We're going to follow the same sort of process that we have been. You got assignment 4 due this week in studio, and you're going to do assignment studio 5 this week in studio. Any questions about logistics or what's coming up on the calendar before we hop into today's topic? All right, fantastic. Then let's have a chat about methods. I did make a repository of review exercises, of review problems for today. So if you would like to follow along with me and do some practice with me, make sure to hop on over to Canvas and click on this link for Module 5 review problems. I've already got it loaded up in Eclipse from the last class. So that's what we're going to be spending a lot of time chatting about today. While you're all, clicking on that link and hopefully loading up the repository in Eclipse, I'd like to start out by just talking about how important of a concept this is for today, right? Consider that every program that we've asked you to write up until this point has had the same basic flow to it. We start at the top of the program and we move in a straight line towards the bottom of the program, right? It's possible that loops might make us repeat sections, and if statements might let us skip certain sections of the code, but in general, that flow is the same for every program that we've done up until today. We start at the beginning, and we just move in a straight line until we hit the end. Methods are going to change that. Methods are going to change that flow of execution quite dramatically. No longer are we going to be moving in a straight line from start to finish. We're going to be jumping around. We're going to be jumping around the code quite a bit. So it is going to make the flow more complicated, actually. It does make things a little bit more complicated to understand in terms of what do we do next? What's the next thing I'm going to do? How do I know when the program's over? Things like that. Hopefully it comes with some benefits. Hopefully we're not just making things more complicated for the sake of making things complicated. And the fact is that, yeah, there are some very important reasons why we do this. We use methods as programmers to define behaviors, to define operations, to define computations that we wish to perform. And so the nice thing about doing it that way is we're really providing a name or a label. Just like we use variables to label our data, we use methods to label our operations, our behaviors, our actions that are being performed. And so if I want to perform the same action over and over and over again, we've got a couple different ways we could think about it, right? The first way we could think about it is, well, I'm going to write the code to make it work, and then if I need to do that set of steps again, I can just copy that chunk of code and paste it again. Right? That's one approach. I could actually paste it as many times as I want. But consider this not all too unlikely scenario of maybe the first time I wrote that code, there was a mistake. And then when I copied the code and I pasted it, I also copied the mistake and I pasted it. And when I copied it and pasted it 50 times, I also pasted that mistake 50 times. And then when I figure out that, hey, there's a mistake in my code, I have to go fix it in all 50 places, right? So copying and pasting code is I don't want to tell you not to do it, right? But anytime you're copying and pasting code in a programming context, I hope you at least consider, should this be a method instead? Because what methods allow us to do, as I said, is apply a name to it, write that code one time, and then reuse that code over and over and over again. And it's that reuse that really provides the value. That's why we jump through the extra hoops of screwing up the flow of our code, right? It's because we can reuse that code over and over and over again in many different contexts and many different situations. As programmers, that is one of our primary concerns. I do not want to copy paste big chunks of code over and over again. I would much rather write that code once, put it into a method, and then reuse that method over and over and over again. So that's kind of the direction that we're headed in with this, and we're going to see all of those things in a lot more detail as we start talking about methods and working through some examples. So let's start out by taking a look at some of these review questions, starting with the top one here. What are the parts of a method definition? There's actually a method definition up here on the screen. This is one, but I'm gonna scroll down here and start trying to piece together another little method definition. And the first two things that you need to define a method, declare a method, are the words public and static. And the text, the prep work did not really explain too much about what these words are for. That was somewhat intentional. Later on in the semester, we'll start to talk about these pieces in a bit more detail. For now, I want you to, as perhaps unsatisfying as it may be, I want you to just treat them as magic words, hocus pocus abracadabra that we need to get our methods up and running. Later on, I'll try and take the magic out of those words and explain what they mean in more detail, but for now, this is just a necessary part of the magic spell. The next thing that comes after public and static, anybody remember what that's called? Up here, we had it listed as void, which is something that's worth talking about, but we also could see it listed as int or double, or what is this called? What is this part of the method definition called? Anybody remember from the prep? Yeah. The return type. Yeah, the return type. So the return type is it's going to be a type, right? It can be an int, it could be a double. Void is a new, we haven't seen a void type before, right? But void is a special return type that basically means there is no return type, right? The absence of a return type. We'll talk a lot more about what it means to return something a little bit later on today. That's one of the questions on our to-do list. But for now, we'll just make a note that this is the return type, and this is what is going to be coming out of the method. So return types are outputs. Return types are the data that's coming out of the method, usually the result. The value that comes after the return type is going to be the name of the method. So we want that name to be descriptive. Remember, we're using methods to help us define behaviors. So we want to describe that behavior. So I might call it say hello, right? If that's what I want my method to do. Okay? After that, we have parentheses, and inside of these parentheses, it could be empty. That's definitely a valid thing. I can have, the parentheses are required. I do have to have the parentheses. I don't have to put things inside of the parentheses, though. It's definitely possible to leave them empty. But let's say I wanted to put something inside of the parentheses. What would be the things that go inside of the parentheses? Anybody remember what I would call the things that go in here? I can give you an example of one. Maybe I would say something like this. What is this an example of? Anybody remember? Starts with a P. Yeah. Parameter. That's exactly right. This is an example of a parameter. Parameters are optional. We don't need them. It's possible to have 0 parameters. It's also possible to have lots of parameters. If I want to have more than one parameter, I can, add on more parameters out here if I want to. It's up to me as the programmer to decide how many parameters I want, usually. when I'm defining a method, and we'll talk about that. We'll talk about how to make that decision a little bit later on. But for now, this is it. This is how we define a method. These pieces are always going to appear. They may look a little bit different depending on the problem that we want to solve, but it's always going to go public static, followed by the return type, followed by the name of the method, and then parentheses around any parameters that may or may not exist for the method. Then inside of the curly braces, that's where we would put the body of the method. This is the behaviors. This is what we want the method to do. So, in this particular method, it's just trying to keep things simple. I'll just put a very simple hello statement, right? Any questions about the different pieces of a method? Okay. The next question is, what is an argument or a parameter? So we talked about where they go, right? And how many we can have. What are they actually used for? I would argue that I'm not using this parameter very well right now. Consider if I didn't have any parameters, no parameters, right? That means that there is no way for me to control this method. That means there is no way that I can have this method behave any differently than what it says right here, because there's no parameters. So if there's no parameters, this method is going to run this way, exactly this way, every single time. So think about what that means then if I want to include some parameters. Parameters are used so that I can dictate, have some influence over how the method is going to behave. So in this particular case, I'm implying that I put in a string called name, and so maybe I want to say hello to this name, right? Maybe I actually don't just want to have a generic hello. Maybe I actually want to say hello to a person. I could incorporate that into this code by using a little bit of concatenation, right? And now when I use this method, it's not just going to give me a generic hello, but it'll actually say hello to whatever name is provided to the method, right? So parameters are used to give us, as programmers, more control over how a method executes. That's good for us because we can then use that method in more situations, and that is our goal. I want these methods to be broadly applicable. I want them to be fairly general so that I can reuse this behavior across many different situations. A method that is only specific and only useful for one specific thing is not as useful to me as a method that can be used in many different places. I really want to maximize how much I'm reusing that code. All right, question number 3. Oh, this says function. It should say method. Sorry about that. That's a me mistake. What is a method call? Can somebody, or let's think about this a different way. Let me ask you a slightly different question that's related to this question. If I run this right now, if I click the go button, what's going to happen? Nothing. Well, wait a second. There's a print statement down here. Shouldn't it print something? No. Why not? Why isn't it going to print something when I click go? You can try it out. Nothing's going to happen. Well, consider this is just a definition. This is just defining a behavior. This is just defining an operation. This just says how it's supposed to work. There's a difference between the instructions that I'm supposed to follow and then actually doing those things. Consider a recipe, for example, right? A recipe tells you exactly, do this thing first, do this thing first, do this thing first, do this thing first. I can give you a recipe, right, to make brownies, but you're not actually going to have brownies until you sit down and do the things on the recipe. So when we write methods like this is just a recipe. This does not do anything, right? This might tell me how to make brownies, but in order to actually make the brownies, I have to say, do that thing. Use this method, right? Do the behaviors that are defined in this method. That's called a method call. That is what a method call is. And so in order to call a method, That's the next question here, right? We type the name of the method. So I would say, in this case, the name of the method is say hello. So I would say hello. Parentheses, always parentheses, always, always, always. And then if there are parameters here, I have to say what these parameters are here. I have to give you a string. This says that in order for this method to work, it needs a name. It needs a name as a string. So in order for me to call this method, I have to provide a name as a string, right? That could come from a variable. That could just be me typing a name directly inside the parentheses. That works too. It doesn't matter where the string comes from. I just have to make sure that there's a string inside of those parentheses to match the fact that this parameter also exists. So now that I have this method call, right, this should execute this code. So this is the recipe. This is saying make the recipe called say hello. Do the thing that is called say hello. So when I run this code now, we'll see, it does say hello to me. It says hello, Doug. Right? Great. But actually, how did that execute? I think that's something that's worth talking about. What order did things happen in? How did it know where to go next? How did it know where to begin? Actually, I kind of want to skip ahead a little bit and maybe shift down and talk about this question right here. We've actually been using methods this entire semester. We just haven't really told you we've been using methods. You don't really have a choice. You have to use at least one method in every program, and that method is called the main method. What's the main method used for? Somebody explain to me in English what the main method's used for? You're close. I feel like you're like so close to the actual. Why did I put this inside of here, right? Why did I put this method call here? Why didn't I put it down here? Or why didn't I even just put it at the end, right, at the very bottom? Why did I put it inside of main? Let's think about it this way. I can create as many of these as I want. If I want to put 10 method definitions here, Eclipse isn't going to stop me. If I want to put 100 method definitions here, Eclipse isn't going to stop me. So I have all of these different behaviors, right? And I say, run the program. Which method is it going to do first? Which one am I talking about right now? The main one. The main method's role in life is that it is the first method. The main method is where we begin. So if I have 100 methods in a file, okay, that's fine. I'm always going to start at main. The first line of code that's going to execute in a program is the first line of code that is in main. And so this, as we can see right here, is the first line of code that exists in main besides the comments, but those don't actually do anything. Yeah? Does the first method have to be labeled main? Yes. Actually, main is a very specific method. It has to be declared like this. If you do not declare main exactly like this, so for example, I don't know why you would do this, but if I decide that main should have a return type of int, well, that's a problem. It's now going to say, I don't know where you want me to start. That's not what main is supposed to look like. If you come in and you decide to say, I don't think this needs to be here, well, Java is going to say, you're wrong. That does need to be there. Otherwise, I don't know where to start, right? So it is looking for specifically this. Specifically this. Yes?
So is void the return, or is main the return?
Void is the return type. Main is the name of the method. This method is called main. It is the main method. Yep. The main method is the entry point to a program. Yeah. But let's get back to the flow. Let's get back to the execution flow of this program, because I think that's really, really important. We know this line executes first, but what happens after that? What are all the things that happen after that? Actually, I want to do something real quick here and show you that, okay, I can actually reuse this method. That's kind of the point, right? To be able to reuse this method. So let's say we'll say hi to my daughter, we'll say hi to my son while we're at it. Let's say hi to my cat and my wife while we're at it, but that's enough for now. We'll stop there. Okay, I want to run you through the debugger and talk to you about the flow of this program. Step through this one line at a time. here I am on line 13. That's the first line that's going to execute, right? First line in main. So I'm going to set my breakpoint right here on line 13. And I'm going to start it up in the debugger. Switch over to the debug perspective. And the one thing that is really important for us to pay attention to now that we haven't really looked at a whole lot before now is over here on the left-hand side. This thing over here on the left-hand side, specifically this part right here, is called the method call stack. The method call stack. It keeps track of all of the method calls that take place. It keeps track of the order that they're called in and the path that we take through the program, which is very important for us. And it's called a stack for a reason, right? As we'll see in just a second, you can see that right now the only thing on the method call stack is main. And guess what? Main is always going to be the first thing on the method call stack because that's where we begin. Main is always going to be on the bottom of the stack. Every time I call another method, I'm going to add another thing to the top of the stack. And then if I call another method after that, I'll add that to the top of the stack. Right? So the stack will grow as my method calls grow. But then what happens when I am done with the method? How does that work? Well, let's run through the debugger and see. First off, in the past, when we've used the debugger, this is the option that I've been using, the step over option. And that'll still work. Pay attention to what happens, right? If I click step over, whoops, I clicked the wrong button. Let me start over again and hit the right button this time. If I click step over, why is it doing that? Oh, I have another breakpoint set down here? That must have been from the last class. I'm sorry about that. I had another breakpoint set down there from the prior section. One more time. I apologize. One more time. Here we go. I'm on line 13, and I click step over, and boom, I go to line 14. But look what happened. It actually ran that method, right? It actually did this. It said hello to me. And if I click step over, boom, I'm now on line 15, and it said hello to my daughter. If I click it one more time, it'll say hello one more time, and now I'm at the end, right? I'm at the end of main. Program's over. But hold on a second. Let's try that again. And this time, I want to talk to you about the arrow that's right next to it, called step into. Step into does kind of as it implies. Instead of just moving to the next line right down here, I'm actually going to go into the method. So this method call says, go to the method that's called say hello, and say hello to this person right here. So you can see I've jumped down here. Take a look at my method call stack. There's main on the bottom. I called the say hello method. That's where I'm at right now. I'm at line 27 in the say hello method, so I see it on the top of the stack. That's where I'm at right now. The top of the stack is always, where am I right now? Where am I right now? So this method is going to do its thing. It's going to print out the message, and you can see that this method is now over. It's done everything that it's been asked to do. So where do I go next? What am I going to do next? Well, I'm going to perform something that's called, well, I don't know if I want to spoil what the name is just yet, but I'm going to use the stack to help me answer that question. This method was called in the main method on line 13. So when I'm done running this method, I'm going to go back to the main method on line 13 and continue on from there. So I always end up going back to where the method was called. Jump to the method, do all the stuff, jump back to where the method call was, and then continue from there. That's how the control flow of our program is going to work. I can show this to you. If I hit step, notice that I'm back in the main method. Line 13 is over, and I'm now getting ready to do line 14, right? And so then if I step into this one, oh, hey, look, I'm in the same method that I was before. I'm reusing this code, right? Saying hello to a different person. But if I look at the stack, notice that, okay, say hello's on the top, but then when this method is over, where's it going to go back to? It's going to go back to the main method line 14, right? Because that's where I came from. That's where the method was called. So we always, when a method is over, we always go back to where the method was called and try to keep going from there. So it's going to jump back and forth whole heck of a lot now. And what makes things even perhaps more confusing is that maybe I'll jump to one method and then jump to another method and then jump to another one and then go back and then maybe jump to another one and then go back and then go back again, right? Like there's no limit to, how many methods I can jump to within a program. Complicated programs, that you'll see this stack get huge. In fact, I think starting next week, I'll be able to show you some examples that have lots on here. So that is, I think, one of the trickier things to get used to when dealing with methods. But again, the reward, the payoff is I get to reuse this code over and over and over again. I don't have to copy paste it everywhere. It makes it much easier for me to keep things clean and organized and manageable. Okay. Any questions about that process? Because if not, I have a question for you. We actually have a name. When this method is over and I go back to main, there's a name for that. It's a very important name. It's on our list of things to talk about today. Anybody remember what that's called from the prep work? Starts with an R. It's on the screen right now. It's a return. It's another name for going back, right? Going back to where I came from. When I hit the end of a method and I look at the stack and I say, where am I supposed to go to? That's called a return. I am returning. That method is said to return from where it was called. So always keep that in mind when trying to figure out the flow. The return means go back to where you came from. Return also is used for something else. We'll talk about that in just a little bit. But first, let's talk about scope. Can somebody define scope for me? Just in a sentence, maybe two, real quick. Anybody have an idea of what it means? What the scope of something refers to? We've actually used scope before. Or, maybe it would be easier to answer this sub-question, right? How do we determine the scope of a variable? Consider this. Maybe you've run into this situation before. I'm writing a for loop, perhaps, right? I create a variable inside of that for loop. Can I use that variable after the loop is over? Am I allowed to use that? If I create a variable in a for loop and then the loop ends, can I still use that variable? No, you cannot. It's not allowed. It's not possible. That's a big part of the reason why we usually create our variables before the for loop, right? So that when the loop's over, we can still see those variables. That's scope. Defined very, briefly, scope is the places in a program in which a variable can be seen, in which a variable can be used or accessed. So the scope is going to be different for every variable within a program, right? What defines the scope? Consider the example that I just talked about. I create a variable inside of a loop. Once that loop is over, I can no longer see that variable anymore. How do I know when the loop is over? How do I know when a loop's over? What do I see in the code to tell me that I've hit the end of a loop? It's not meant to be a trick question. Yeah, brackets. Curly brackets are used to define scope. Curly brackets are used to define scope. So if I create a variable inside of a pair of curly brackets, as soon as I leave that pair of curly brackets, I can no longer see that variable anymore. A variable can only be seen within the curly brackets where it was created. Does that make sense? I hope. Think about what that means for us today. The reason why we're talking about that today, notice that every method that we create has us use curly braces. So think about what that means. If I create a variable within a method, as soon as I leave that method, I can no longer see that variable. Or the more practical way that we usually phrase that is that I cannot see variables in other methods, right? If I'm in one method, I cannot view the variables that exist in another method. It's not possible for me to do that. They only exist within that method. And the only variables that I can see are the variables that were created within the method that I'm currently in. Let me show you an example. In my main method, let's go ahead and say I want to create a variable called x and set it to be 7. Doesn't really matter what variable you create or what value you use. Just create a variable, right? I still have my breakpoint set from before on line 14. So if I run this debugger, there's my variable called x with a value of 7. Watch what happens when I click step into. Poof, that x variable disappears. It is gone, right? I cannot see it, except once I'm done with this method and I go back to main, well, hey, there it is again, right? So x only exists within main. It does not exist outside of the main method. Does that make sense? The scope of x is the method and where it was created. We can actually, yeah.
So if you create an integer within the string name.
You read my mind. Yeah, that was exactly where I was going with this next. Let's try it out. Think about the broader implications of this. Can I make an integer variable x here? Yes, I can. It's not going to complain because inside of this method, it has no idea that this variable called x exists. There's no problem with that. However, this and this are two separate variables, right? They are not the same variable. They are two separate variables that happen to have the same name. That's it. That's it. And you can also view that in the debugger as well, right? Here I am in main, and I can see that my value of x is 7. But as soon as I step into this method and step through it a couple times, you can see that, okay, here's the value of x that I created. It's 2. Okay, but if I continue on and I go back to main, oh, x is now 7 again. Those are two different values of x that it's keeping track of. Two separate, completely separate variables, and they don't know about each other. This version of x has no idea that this version of x exists. No idea. So this is a good thing, I think, from the sake of keeping our methods, clean and concise. We don't have to worry about interference, right, from outside methods. But kind of a bad thing if I genuinely, let's say I genuinely do need this value in this method, right? I do want to access this variable from down here. How can I do that? Well, we have ways of getting information into and out of methods. How do I get information into methods? We've already talked about this. If I really wanted this value into a method, the proper way to get that value into the method is to make a new parameter for it. Add a new int parameter, and then I can plug that integer in all day long. Parameters are the way that we get values into methods. And return values, which is our next review question, our next little topic to chat about, are the ways that we get values out of our methods. So if you have a value and you're like, why can't I access that value from this method? That should be a clue to you that maybe you need a parameter. Maybe you need to add an additional parameter to pass that value in. Any questions so far? Let's chat about this last review question. What does it mean to return something? It actually means two things. So I've only actually covered one of the two things that a return statement does for us. The first thing that a return statement does is it, stops, or I'm sorry. The first thing that a return does is it stops the method, goes back to method call, right? At the end of a method, the return says go back to where the method was called. That's the primary thing that the return is used for. But it is also used to signify the output of a method. So actually say the result of something. So the method that I used here has a return type of void. That means that there is no output. This method is not going to output anything. It's not going to give me a value or do anything like that. In order to illustrate return values, I'm going to make another very, 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 very simple method to illustrate this fact that just adds two numbers together. In practice, I would never make this method. I can just use addition directly. But I'm trying to get you, show you an example of how return values work. So I'll make a method called addInts, and it'll take in two parameters, int x and int y. Okay? And I can create the sum, and then finally return the sum. So here, this is what's called a return statement. In this case, again, this does two things. It's the first thing that it does is it says this method is over. In fact, I want to illustrate that point. If I come down here after the return statement and I try to say, int y is equal to 7, and I try to keep going, right? I try to put more stuff. Look at what happens. Eclipse gets mad at me. Oh, duplicate local variable y. That's not what I meant. Let me say z. So I don't have that. Eclipse gets mad at me. It says unreachable code. Quite literally, it's telling me this line of code will never get executed ever, 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 because this return statement says we're done. Go back to where you came from. Go back to where this method was called. Do not do anything else in this method. So putting lines of code after a return statement is useless, and in fact an error. Eclipse will not let you do this. The second thing that a return does is it says that this, when I return something, it says this is the result. You told me to do this behavior, and I'm telling you that this is the answer. This is the result of that behavior. This is the output. Yes?
So is it like if you were to call add-ins like above there?
Yeah, which is what I'm going to do in just a second. Yeah.
Could you only do it once then? Because there's the return?
No, actually, that's a good question. We can use it as many times as we want, but let's talk about how that return affects the way that we call it. When I say add ints, I have to provide parameters to add the 2 and the 7. So this says go down here, take the values of 2 and 7 for x and y, add them together, that should be 9, and then return 9. So that does two things. It says go back to where you came from right here, but because there's a return type, it also says take this value of 9 with you when you go back there. So not only am I returning from where I was called, but I'm bringing this return value with me. I'm bringing this sum variable back with me. Now, when I run this one through the debugger, I'm going to turn a breakpoint on here, line 25, and actually turn this breakpoint off. So the only one I have set right now is right here when I do add ints. Let's see what happens. So here I am on line 25. It's about ready to add these two integer values together to make 9. So I go in, I compute the sum. There's my 9 right there. And then it says, all right, go back to where you came from. There's this message up here that says add ints returned a 9, which is great. That's exactly what I thought was going to happen. I went back to where the method call was, and this value of 9 came with me. However, the way that I called this method is basically saying, oh yeah, thanks for the 9, and then throwing the 9 in the trash. Saying like, right? I have a value of 9 here. If I want to keep that value of 9, if I want to do something with that value of 9, or whatever value I get, right? It might not be 9, it could be anything. I need to store it. I need to save it. I need to create a variable for it. So typically what we would do is say, something like this. When I have a method, and that method has a return type that is not void, right? Notice that for the void methods, I didn't bother with this step. So if a method is void, I can just call it, put in any parameters, and move on with my day. But if there is a return value, if the return value is not void, it's going to give me a number back, then I'm probably going to want to create a variable to capture that return value, because otherwise I won't be able to use that 9 in my code, right? Now that I have this, I can print it out. I can do more arithmetic with it. I can plug it into another method if I want to, right? And pass data all throughout my program. This is a very important part of programming, actually. So yeah, 99 times out of 100, if I'm calling a method with a return value, I'm sticking a variable out in front that has the same type as the return type of that method. It has to match, right? It has to match up. And so now when we run this through the debugger, notice that, yes, it does step into the method. It computes the sum. It returns that value of 9. But now that I have this variable out here, right, I can see that, OK, that result got stashed into that variable. And I can do whatever I want to with it from here. And as to your question before, right, can I call this method multiple times? Absolutely. In fact, if I want to, I could very easily, copy that and plug in 2 different numbers, like 3 and 3, and run this again. See that the first time I get 9, and then the second time it'll take in 3 and 3, right, as the parameters. Sum. There we go. There's my 6. That gets printed out. So 2 things that return statements can do for us. In a void method, the only thing that it does is say go back, because there's nothing to return. It's void. But in a non-void method, it says go back, and it also says take this value with you. One other thing that I want to point out is that if I have this as an int, it's non-optional, right? I have to return an int. I have to send an int back. I can't skip it. I can't just return nothing. That's not an option. The message here is going to say, this method must return a result of type int. You told me you were going to give me back an int. You have to give me back an int. You can't just not give me anything. Also notice, another thing to notice about return values, return types, for parameters, I can have as many of these as I want. I can just comma, 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 add on as many parameters as I want. But for return values, that's not true. You just have the 1. And it's always 1. Well, unless it's 0. Those are my 2 options, right? 0 if it's void, 1 if it's anything else. And that's it. I cannot return more than 1 thing. It's not possible. That might seem like a pretty restrictive thing. It can be. There are ways that we can get around that restriction, and we'll talk about those as we go through the semester. But for now, the important thing for you to keep in mind is that, yeah, I can have as many of these parameters as I want, but for return values, just the 1. Only the 1. It's possible. Let me fix this error. I think that does it for the basic review. I want to spend the rest of the time. I brought some practice problems with me that we can talk about. But before I do, does anybody have any questions about anything we've discussed so far, any of these general concepts? I'm happy to go through any of them again, re-explain, clear up any rough patches. Yes?
If you have like 2 data types in your parameter, I just put 2 types in it, and it like kind of broke part of my code.
Okay.
How exactly do you like use
multiple parameters?
Multiple parameters.
Yeah,
or
that's
multiple parameters of different data types.
That's a great question. So the answer is that this order matters. So if I list the int first, then I have to give an int first. If the second one is a string, for example, then this always needs to be a string. So it's probably unhappy with, I know it's unhappy with me because it's going to say, this is supposed to have an int and a string, and you gave me an int and an int, so it doesn't match up. So the order of the parameters says integer first, then a string, then whatever else next. And I have to, when I call the method, have to supply them in exactly that order. Yeah. Any other questions? That was a great question. Any other ones that I can address before we hopefully get some practice in? Okay, then before we do some of these exercises, I also just want to pause for a moment and see if anybody wants me to go through any of the practice problems from the prep work. I'm hoping that you had a chance to look at some of these prep work problems. Last class, they asked me to go through the shipping cost calculator example, and we don't have to do that if you don't want to, but if you want to do that example or any of the other examples, does anybody have one they would like to see me go through? If not, I got some practice problems of my own that I'd like to talk to you about, but I wanted to give you a chance to request a walkthrough of one of these. Going once. Okay. Not a problem at all. We have a little bit over half an hour left, so I think we should be able to get through at least 2 of these exercises that I brought with me today. We'll see how far we get. Module 5 review. Yes. We're going to start with this one. This one here, exercise 2, first and last. So I'm going to kind of, these do kind of run in difficulty order. I think this is probably the easiest one, and this one is a bit more tricky, and this one is even trickier still. So this one should hopefully not be too bad, but I'm going to give you some time to practice it. Before I turn you loose on it, though, let's talk about it for a little bit. Just make sure everybody's on the same page and get started on the right foot with this particular problem. You're being asked to write a method that takes in an array of integers and then returns the sum of the first value from the array and the last value from the array. And then it also wants you to call your method to ensure that it works. Well, I'm actually going to maybe do this part first, just to kind of give you a little bit of a push in the right direction on this problem. In my main method here, I'm going to start by creating an integer array that we can use to test. So I'll say test array. And you can use whatever values you want, right? But I'm just going to make a simple little 1, 2, 3, 4 array of integers. So with the array that I created, right, by the time we're done, it should take this 1 and this 4 and add them together to make 5. That's the goal for our method. But we don't want it to work just for this array, right? We want it to work for any array that I pass in. Okay. So in order to check this, I need to call the method and pass it in. Well, the method doesn't exist yet. So first we need to think, what should this method be called? It'll probably be called something like sum of first and last. Or I don't know, maybe you don't like that name. You're allowed to call it something else if you want to. You don't have to use the same name that I do if you don't want to. But I do like to make sure it's descriptive of what's happening. And then I'll pass in test array as the parameter here. But wait a second, it says that this should return the sum. So that means there's going to be a return value. There's going to be a value coming out as well. And so we ought to capture that. So I should say something like int result is equal to this method call. And then finally, in order to make sure that it works properly, let's print out the result. Okay. I have done this part for you. Call your method to ensure that it works. Your task is to write this method. So you need to come down here and start defining this method, sum of first and last. I'm going to give you a few minutes to work on this. Talk to your neighbors. You don't have to work by yourself. Please talk to your neighbors. Work on it together. I'll give you 5 to 10 minutes to work on this one. I'll do a couple of laps. So if you get stuck or have any questions, need some help, feel free to flag me down, and I'll regroup us in just a little bit and go through the answer with you. Okay? Let me know if you need any help.
Okay, so I don't need to do like a totally
No, no. No, even less than.
with
M?
plus zero plus
It doesn't matter.
plus that might actually
Good.
got it.
Okay, now you're thinking. That's where you would go.
Oh, sorry.
I forgot how to do escape. Shit.
No, that's not what it is. Good, now your turn. That'll be a win for you.
Scalar system. Let's see this. What
Source I can still see for me.
What do you mean? Like it didn't let you in? I mean,
Uh-oh. I can go the wrong direction. It's usually this way. Does it though? Does it though? Come on, swap your turn.
Maybe one more minute on this one.
So you call your
it's inside the
method
name.
to summon first and last. Once you find them, you say what it is to summon first and last. You say, okay, so it takes the input of an array. Yeah. Okay, and so now what you do is for an array that works call.
Return. Oh, pretty bad. Yeah, and it's here. Yes, and so put that. So this returns nil. It's assigned to the result. Oh,
Yeah.
so that's what so that also
Right.
says.
And so
Oh,
what is the other? How many bits?
this is also first and last name. So now it's nil. No, and now it puts the value of nil in result, and then it goes up. Yes.
I see.
And this will work for arrays.
So if I do loop every time.
All right. I heard some great conversations. I think some of you have managed to figure this one out, which is wonderful. I'd like to walk through a solution. Totally okay if your solution doesn't look like mine. There's definitely more than one way to do this. But we need to create this method. We need to create this sum of first and last method. So I'm going to start out with the magic words, right? Have to put in the public static. That's a requirement. And now we get to, the first part that takes a little bit of thinking. Void is nice to use, but actually it says very clearly it's going to return the sum. And so I don't think void's going to work. But I gave you the big hint right here, didn't I? So as we've talked about, if I return something, I'm going to store it in a variable, and that variable is going to have the same type as the return type from the method. If that doesn't work, if you're having trouble understanding that, consider that it's an array of integers. If I add the first integer and the last integer, the result is going to be an integer, right? That's another way of thinking about what the return type should be. This needs to be an int for the return type for this particular problem. Then we're going to type the name of the method, which I already kind of gave you a suggestion. You didn't have to call it that if you don't want to, but that's what I decided to call it, so I'll go ahead and include that. And now we have to think about what the parameters are going to be. I know there's going to be at least one parameter, right? In fact, it tells you that it takes in an array of ints, and this is one of the trickier parts. If I say something like this, I'm close, but not quite there. What do I need to do to say that this is one int? What do I need to do to say that it's an array of ints? I need the brackets. So any types will work here, and this is a valid type. That's an array of integers. That's what that type is. So can totally do that. Totally pass in an array of ints here. That'll do it for the method declaration, for the definition of the method. We now have to do the actual work. So you can do this all in one line. I definitely could pull it off in one line if you wanted to, but I'll break it up just to make it a little bit more clear what's going on here. I'll grab the first value out of the array. That should hopefully be the easy one. It's always going to start at 0, right? Getting the value out of the last value out of the array. What's the position of the last value? The length minus 1. So I'd have to say array, and then inside the brackets here, this is a little bit long what I'm going to put in here, but array dot length minus 1. I can put that inside the brackets. That's an okay thing for me to say. Some people may have felt better defining that in as a variable and then putting the variable inside the brackets. Also okay. Don't have a problem with it. But that is where the last value is going to be. And then finally, I can create a sum variable to add them all together. And finally, return my result. As I mentioned, you can do all this in one line. You actually don't need to break this up into chunks, but this is, I think, a little bit clear. Question?
Yeah, just trying to understand. So for the second method,
Mm-hmm.
how does that method know what the values in test array are if you use the array?
Yeah, so great question. I think what you're asking about, and please correct me if I'm misunderstanding, but here I plugged in something called test array, but the name of this parameter is called array, right? Consider this is a recipe. So when I have a parameter here, I'm just saying give me any old array that you have laying around. It doesn't have to be this specific array. It could be literally any integer array in the world.
So it creates an array basically based off the array that you feed into the int result.
You're close. I would actually, and I'll once again use the debugger to kind of show this to you. When I call the method, what it does is it takes this value, and there's sort of an implied variable assignment happening, right? I'm saying array is equal to test array, and then run all the code inside the method. Does that make sense? I can actually show that to you in the debugger. I'm glad you asked this, by the way. Great question. Once I start up my debugger, hello, yes, run please. Here I am. Okay, I'm on line 11, and if I look over here, I can very clearly see test array is equal to 1, 2, 3, 4. As soon as I step into it, notice that, okay, now I have a variable called array that is also equal to 1, 2, 3, 4. How did that happen? Well, when I called the method, it said array is equal to test array, right? It does an implied variable assignment there to pass the values in. Yep. It's not creating a copy. It's actually assigning. Yeah. Mm-hmm. Yeah, great question. Great question. Any other questions? I want to actually repeat a question somebody asked me that because I thought it was a really good question. Somebody asked me, is it okay to put the method down here, or can I put the method up here if I want to before the main method? The answer is it doesn't matter. actually. Notice I just grabbed the whole thing and moved it up. And if I, run the code again, it still prints out 5, just like it did before. The order that the methods appear does not matter. And again, to understand why, consider that it's always going to start at this one. Regardless of where this method is, this is the starting point. So it doesn't matter what order I put them in. It's always going to start at this one. And again, one more thing before we wrap this one up and maybe move on to our next exercise. We also should probably be more thorough about testing this, right? For starters, let's make sure that if I add more values here, right? Notice I didn't change the last value, but I just made the array bigger, right? Should still work. Should still properly compute the sum of the first and last value, and it does. That's good. Same thing if I make it shorter. If I just stick, 2 values in, should still work. So definitely make sure to test your methods thoroughly. Running one test on a method is not good enough to say that it's going to work for every situation. You have to think about the possible different arrays that you might deal with and make sure your method's capable of handling all of them. Yeah. Any final questions on this exercise before we do another one? Oh yeah, in the back. Absolutely, yeah. You just wanted to see this guy? Yeah, cool. All right, we have about 18 minutes left in class. I think that's enough time for us to do one more practice problem. So we're going to do this one next, adding arrays. I'll give you a head start on this one, just like I did on the last one. So this one's definitely a bit trickier. I don't want to sugarcoat it. I want to make a method. This method is going to take in 2 arrays, and it's going to add them together. But notice that in this given example, it's very possible that these arrays will not be the same size. So that's something that you're going to have to think about and consider how to deal with. Look at how it's adding these up together. So the 3 plus the 1 gets me the 4. The 4 plus the 6 gets me the 10. And now I've run out of values, right? The short array is out of numbers. So the 5 gets added to 0 to become the 5, and the 1 gets added to 0 to become the 1. Or, nothing to add since I run out of values. So I want to make a method that takes in this array and this array, or any 2 arrays, right? And creates this one coming back out. Just like before, I want to give you a push in the right direction by setting up the main method with a method call for you to use to verify your work. So I'm actually just going to try and recreate this exact example. That's what I'm going to try and do. First is equal to 3, 4, 5, 1. The second array is equal to 1, 6. Now I'm going to plug 2 arrays in, and I'm going to get 1 array back out. 1 array is my return value. So int result is equal to, what do we want to call this method? Add arrays. Seems like a good method name to me, right? And we'll plug in first and second as the 2 parameters. And before I turn you loose on this, one more thing. If I want to verify that this result is correct and print out this array, what do I have to do? I have to loop, traverse it. I have to iterate. I is less than result.length, I plus plus, system.out.println, results at I. So here is the code that sets up this exact example, right? This exact addition. Your task is to create this method that performs this addition. It's trickier. I'm going to give you a little bit more time on this one, but I definitely will go through the solution before we leave. Probably get your attention around 3:42, 3:43. I'll be around. If you have any questions, let me know. All right, this one was definitely a bit trickier. If you struggled with this one a little bit, if you didn't quite get it finished, I think that's very understandable. But I want to make sure that you have a solution before you leave here today. I don't want to leave you hanging. So I would like to go through a solution with you. Just like almost all problems in this class, there are many ways to do this. So if you were trying a different approach or found a different approach, that's totally cool. But I'm going to show you an approach to wrap up class today. Let's start off with the method definition. We know we need our public and static because that's a requirement. And then our first little tricky bit refers to the return type. Just like we saw in the last example, we can have arrays come in as our parameters. We can also have arrays go out. So the return type of this needs to match the variable that we used here. That's going to be an integer array. So the sum of two arrays is also an array. So I expect this method is going to give me an array back out that represents the sum of the two arrays going in. That's the idea behind that return type. Next comes the name of the method. And then inside the parentheses here, we need the parameters. So I might call this 1 and 2. And again, you might be saying, why didn't you call them first and second like you did up here? Well, these are different, right? These are two different variables. They're different parameters. And yeah. Okay, so I think the first tricky thing to reconcile with this problem is the fact that these arrays don't have to be the same size. If they did have to be the same size, that would make it much more straightforward, but they don't. They don't have to be the same size. So I hope the first thing that you kind of maybe thought of was, well, the result array has to be the same size as whichever of these two is the biggest, right? So the size of my result is going to be the same as the bigger of these two arrays. But we have to figure that out. Is it possible to write a method that just assumes that this array is longer than this array? Yes. But I would argue that that method is not nearly as useful or as applicable as a method that doesn't enforce that restriction and allows me to pass in whichever two arrays I want in whichever order I want. So I'm not going to assume that this array is bigger than this one. I'm also not going to assume that this array is bigger than this one. I'm going to ask. I'm going to figure it out definitively which array is bigger. So, you know, the way that I might do that is, there's multiple ways you could do that. Math.max, I think, is a really clean way of doing it, but another way of doing it with an if statement might look something like this, where I say, all right, I'm going to make a variable called max length, start it out with the length of the first one, and then say, all right, if 2.length is greater than 1.length, then, okay, max length should actually be 2.length, right? And so then by the time that I get through this if statement, I know that this will be the maximum length of the two arrays I've been given. Everybody with me so far? I hope. Okay. I can now create my result array. I know my result array is going to be this long, right? So I'm going to go ahead and create an array to hold my result. And I'll just create an empty array for this purpose. So here we go. I have my empty result array here. And the way that I want to solve the actual addition part, which is the part that we have left, is to, recognize the fact that this result array, since it's empty, starts out as 0, 0, 0, 0, right? So what I can do is I can take advantage of that fact. I can say add this 3 to this spot, add this 1 to this spot, add this 4 to this spot, add this 6 to this spot. And then eventually I'll say, okay, add the 5 to this spot, and oh, there's no more values to add here, so I'll just skip that one. Add the 1 to this spot, and oh, there's no more values in this array, so I'll just skip that one. So in other words, we need to check and make sure before we do any addition that there actually is a value for us to add, right? And that we haven't run out of values in one of the arrays. Let's go ahead and start to tackle this. I need a loop. I hope that's obvious that you need a loop here. If it's not, I'd love to chat with you about that. But we do need a loop to visit each element of my result. So I'll go ahead and say, you could say result.length here. You could also say max length here. Potato, potato, right? Same thing. But here's the real tricky part. I need to make sure that I have a value in the array before I add it to the result. So in other words, if I is less than, we'll say it does, which array we're gonna have to do them both, right? Because it's possible that, so in this example, this array is shorter, but it's possible that this array is the short one, right? So it's possible for both arrays to be the short one in this scenario. So we have to actually be careful about how we do this in both cases. I'll say if I is less than 1.length, then I'm gonna store, or actually I'm gonna do plus equals. So I'll take the value out of the first array and I'll add it to my result array. And then, surprise, surprise, I'm actually going to take this same if statement and copy it and then just change this to say 2 instead, right? If I is less than the length of 2, meaning I haven't run out of values from this array, then I'll grab a value out of that array and add it into my result. As soon as I run out of values, right, then this if statement will say, whoop, I is too big, you've ran out of values, don't try and add them, right? They don't exist. They don't exist anymore. Could I make this an else if? What do we think? No. No, why not?
The first if statement is true and the second if statement won't be true.
If this one is true, then this one won't get executed. But it's very possible that I is, so if I is 0, right, I need to pull a number from both. So it's independent. And this is a case where actually we don't want to use else ifs. We do want to keep these two if statements separate. If I haven't run out of values in the first array, copy values from the first array. If I haven't run out of values from the second array, copy values from the second array. They're not related. Those two facts are not related to each other, right? So those two if statements should be kept separate. Let's try it. Oh wait, one more step I forgot to do. And you can see Eclipse is complaining. I told it that I was going to give it an integer array with the answer, so I have to actually return an integer array, and the integer array that I created for this purpose is called result. So that will be what I return. Let's try it. Hopefully I can run this and see the result real quick. I know we're almost out of time, but I do want to show you that there's the 41051, just exactly as it's shown here. And then real quick, because I don't want to waste your time, notice that if I switch the order of these two so that the short one is now in the first position and not the second position, right? I can run it again, and I should get the same answer back out. Addition does not care what order the values are in, and so I get the same exact answer back out. So this code here, notice it is a bit more complicated, but there's nothing in here that we really haven't talked about before, that we really haven't seen a whole lot before, aside from this method stuff. I'm out of time though, so yeah, let me know if you have any questions about this. Happy to chat after class. Otherwise, enjoy the rest of your week, and I will see you either in the labs or back here next week.